Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Every organization holds a messy mix of information, from public announcements to confidential designs, all stored across laptops, phones, email, and cloud drives. Treating every file as equally sensitive wastes time and budget, while treating everything as harmless invites breaches and embarrassing mistakes. Data classification solves this everyday problem by creating simple labels that match protection to real risk, so valuable information receives stronger safeguards and low-risk information stays easy to share. A clear classification approach also helps people make quick, consistent handling decisions, which reduces confusion and accidental exposure. Most importantly, classification turns vague worries into specific rules that can be trained, measured, and improved over time, which is how organizations steadily lower risk. Most organizations pick plain names for classification levels so people remember and use them in daily work. A common set is public for information that can be shared freely, internal for low-risk information meant only for employees or trusted partners, confidential for information that could cause meaningful harm if exposed, and restricted for information that could cause severe harm or violate laws. Some organizations add a top tier like highly restricted or rename levels to fit their culture, which is reasonable when the intent stays clear. The important idea is separating low-risk information that needs minimal controls from high-risk information that needs strong controls. Simple names, simple criteria, and clear examples help people label correctly the first time. Classification works across different kinds of information and different moments in the information's life. Structured data is information arranged in fixed fields, like a customer table in a database, while unstructured data includes free-form items like documents, presentations, emails, and images. Data at rest means stored on a device or service. Data in motion means moving across a network, and data in use means being processed or viewed by an application or person. These distinctions matter because controls change with context. Encryption at rest protects stored files, while encryption in transit protects network traffic. When labels follow the data through these states, safeguards remain consistent even as information moves across systems. Certain categories are sensitive almost everywhere and should map to higher classification levels by default. Personally identifiable information, also called ID data, is any information that can identify a specific person, such as name combined with contact details or government numbers. Cardholder data includes payment card numbers and related verification details that enable a transaction, which criminals actively target for fraud. Health records contain medical details that people consider deeply private and that regulators protect because misuse can cause serious harm. These categories deserve careful definitions, concrete examples, and unambiguous handling rules, because mistakes here quickly become costly incidents, regulatory violations, or lost trust with customers and partners. Laws, regulations, and contracts strongly influence how labels are defined and enforced inside organizations. The General Data Protection Regulation, GDPR, sets strict rules for personal data of individuals in the European Union and drives higher handling expectations for many companies. The Health Insurance Portability and Accountability Act, HIPAA, protects medical information in the United States and requires safeguards and accountability for covered entities and their partners. The Payment Card Industry Data Security Standard, PCI DSS, sets controls for storing, processing, and transmitting cardholder data, which service providers and merchants commonly must follow. Contractual obligations with customers and vendors often add handling requirements, which classification levels should reflect clearly and consistently. Clear roles and shared accountability keep classification decisions reliable over time, even as people change jobs or systems evolve. A data owner is the business leader responsible for defining the label and the intended use for a data set, while a data steward helps apply those decisions day to day by maintaining quality and access lists. A custodian operates systems that store or transmit the data and enforces technical controls according to the label's handling rules. Individual users follow the rules when creating, sharing, and disposing of information, which includes reporting issues when they spot mislabeling. When everyone knows who decides, who enforces, and who uses, disagreements shrink and corrections happen quickly. A simple classification policy explains the purpose, scope, roles, label names, criteria, handling rules, and exceptions, and review cadence in straightforward language. The policy should list where it applies, such as endpoints, email, cloud storage, collaboration tools, and databases, so coverage is unmistakable. Each label needs a concise definition and a handful of plain examples that match common work products like spreadsheets, proposals, code repositories, and support tickets. Handling rules should state what to do with access, sharing, encryption, retention, and third-party transfer for each label, using words that map to actual tools and processes. A short section on exceptions and periodic review helps the policy stay useful as the organization changes. Choosing the right label depends on impact thinking grounded in the confidentiality, integrity, and availability CIA model. Confidentiality impact considers how harmful unauthorized disclosure would be. Integrity impact considers harm from unauthorized changes. And availability impact considers harm from downtime or loss. Harm can be legal, financial, operational, or reputational, and the combination should guide whether information is internal, confidential, or restricted. A practical method is to ask what could realistically happen, to whom, and how costly or lasting that harm would be, then to choose the lowest label that still prevents that harm. This approach avoids overclassification, which clogs work, and underclassification, which invites breaches. Labels only help when they are visible and machine-readable, so practical tagging methods matter. Document headers and footers can show the label in human-friendly text, while metadata fields inside files store the label for tools to read. Email subject tags and banners remind recipients of handling rules and help gateways apply transport policies that match the label. Repository and folder labels make bulk actions possible, such as applying stricter permissions or retention settings across many items. Integrated tagging enables data loss prevention (DLP) tools and data catalogs to recognize sensitive information automatically and apply consistent controls even as people collaborate across systems. Each classification level should map to specific handling controls so that everyday behavior becomes predictable and consistent. Public information can be shared broadly and stored without special safeguards beyond basic hygiene, while internal information should require account authentication and approved work tools. Confidential information deserves restricted access, encryption at rest and in transit, safer sharing channels, and defined retention limits to reduce long-term exposure. Restricted information should add stricter access approvals, detailed logging, more frequent reviews, and vendor handling requirements that contractually mirror internal safeguards. When people can point from a label to a clear control set, training gets simpler, audits become straightforward, and mistakes become less frequent. A short scenario shows how labels guide decisions that feel reasonable to everyday teams. A marketing brochure that will be posted on the website is public because disclosure harms nobody, so normal sharing and storage are fine. A spreadsheet of customer email addresses is confidential because it contains personal identifiers that could lead to privacy complaints or phishing if leaked, so it deserves limited access, encryption, careful sharing, and a short retention period. Application source code for a new product is restricted because unauthorized access could enable theft, tampering, or severe outages, so it requires tight repository permissions, strong approvals, encryption, and detailed logging. These decisions feel intuitive when the labels and rules are plain. Discovery and inventory practices keep classification grounded in reality rather than paperwork alone. Automated scanners can search endpoints, file shares, email, and cloud storage for patterns that indicate sensitive content, then suggest or apply labels according to policy. Data catalogs record where important datasets live, who owns them, which systems touch them, and which labels and retention rules apply. A living data register links those catalog entries to business processes, so the organization knows why the data exists and when it can be reduced or deleted. Regular reviews with owners and stewards keep the register accurate, while reports show progress and spotlight problem areas. Consistent labels help organizations match protection to risk, communicate clearly, and focus security effort where it matters most. A workable program starts with a few levels, a short policy, and practical examples that people can apply confidently during normal work. Over time, training, periodic audits, and policy refreshes strengthen alignment between labels and controls, which reduces accidental exposure and costly surprises. Small, steady improvements create lasting habits that scale as systems, teams, and regulations change around the organization. A well-sorted vault keeps valuable information safer without slowing the everyday work that depends on it. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.